So for every line, we have this. Some of them I don't have run off yet, so you get on the module that we don't have it, then this would be where you'd go. So it's inside course content, and then inside the manufacturing line documentation, and then the Amtro line. So we got all the documents on the Festo. While we're not going to deal with Festo, of course, the group is not big enough, but also it's not set up to tear apart right now because of the way it runs its pneumatics. So which station we want to look at? So here's the pick and place, which we've been looking at. And so what we have inside here, these are the whole documents for the thing. So we start off with an overview of what the thing's supposed to do. And we, yeah, I just made it visible. I mean, so if you so if you wasn't there a second ago, it's not going to. Okay. Then the construction. This is the image basically that shows you the location of the main. So you will be using these a lot. In fact, what we'll probably do, I'll probably do is just go ahead and run these off so you can put it up on your whiteboard, right? Because this is really good because what they do on the line is they label the actuators, I think, but they don't label any of the sensors, and this shows you the location of the sensors. This shows you the actual nomenclature for the switches, and then over here it actually tells you which PLC port these are assigned to. Now remember, the Siemens PLCs, all the ports are D, right? So on ours, ports D0, 1, and 2 are inputs, and then 3 and 4 are your outputs. Okay? Everybody okay on that? So notice over here they say I0. Over there it's going to say D0 on the PLC itself. This is what we would do if we were programming the PLC and we wanted to use that input, then that's what we would call it. We'd say I, which means it's an input port, right? You understand that? And then 0 is the byte number. There's 8, so there's 8 bits in a byte, which would mean there's 8 input ports per byte over there. So Siemens runs in groups of 8s, and Allen Bradley runs in groups of 16. So that's just something you'll learn when you get there. So like input module or word 0 for Allen Bradley would be 0 through 15 before it moves over. But Siemens runs in groups of 8s. The next one is the I/O terminal. This guy gets kind of confusing because we got several terminals on there. Okay, so no, this is okay. So this is so what they do on this one, if you notice the numbering, is they number the terminal box 1.7. So they don't define it if it's an input, and they don't define it as an output. But remember, inputs are 0, 1, and 2, and outputs are what? 3 and 4. So this is 1.7, so that's input 1.7, right? You understand? That's the way they label the board. And so it's not being used. But right here, this N1.5, this is being used for this sensor right here, right? 3B2. So that would give you a real fast location. This would be real good when you're trying to figure out what terminal board that sensor goes to, right? Y'all understand that? So this actually gives you the name. We have one of these for each module, which would help us locate that. Of course, these are the pneumatic diagrams. When it pops up, these are the pneumatic diagrams we went through. Y'all got any problem with these? Because on the first test, the main one of the main things, besides for safety, it's just going to be basic symbols, right? Because if you don't know the symbols, you can't read the diagram. Okay. So I gave y'all that handout that's got the symbols on it, right? Everybody okay there? What's that? Safety. Just basic overall sensors, and it'll give you a picture of a sensor. In an application, you have to figure out what type of sensor that is, right? You understand that? And some of the questions came right off a Siemens exam. So, this is pretty close to the other one. This just gives you the port number. It doesn't tell you the port numbers that it's assigned to. All it does is give you. So we probably won't do that much. Then we have this is the function chart, right? This is the step chart, which we've already looked at. And now that you make it, you understand these. So on the line, this shows what that movement sent, that triggered, and then the arrow shows it, what was the effect of that, right? That makes sense now? Then this is the sequence, the step chart. Now this is really neat because this would be really good for actually troubleshooting the PLC. So right off the bat, y'all see this? So what it does is it tells us to start this condition. I can look at, so if my thing won't start, I hit that button, it don't do anything. I can go to that PLC and I can look, and it says that input 0.0 should be a what? That light should be off. This light should be on, this light should be on, this light should be off, this should be on, this should be off, this should be on, this should be off, on, right? You understand? Which is really, really neat. So if I go over there and hit that button, it don't start. Well, right off the bat, I can go to this diagram right here and see what I'm having problems with, right? Yeah, real fast, because now you're trying to figure out, okay, what's required for the start condition. Well, this right here tells you what's required, but not only that, it tells you what port to look at on the PLC. And it tells you whether that light, a 0 means the light's going to be what? Off. A 1 means that light should be what? On. So right off the bat, if we're having a problem with it starting, then we can have that. And then it's got the steps. So here's the steps. So it gets all the way through step 5, but it don't go through step 6, right? You understand? Well, this will tell us what's required for what? Step 6. So this is a really, really good chart to help you really troubleshoot. That would be, if I got into a plant and these was not available, that would be one of the first things I would try to do is develop one of these guys right here. Because this would help your technicians out so fast as far as getting these lines back up and running. To you as a technician, it's not much, right? You understand, but to a plant, that line could cost $1,000 of every minute that it's walking. Yeah, I was looking at, it would be a good suggestion just to set up this chart. Just get out there and watch it on the startup and see, okay, before you press start, let me go over there and look at these PLCs and documents what's required to start. If you get that opportunity, you'd probably get an attaboy for that one, especially the first time it went down. Especially the first time it went down and you fix that sucker in hardly no time at all. This is getting kind of confusing. This is the actual flow for the thing, but it's okay. So this basically shows you the flow, right? This is exactly how it flows. It shows you what's electrical, what's pneumatic. I don't know why they call it a flow chart. It basically shows you how things connect up to the wall. It don't give you, but it gives you the overall. And I can't remember, what's the last one on that? Oh yeah, so this is basically just another variation of the function chart. It's just a little cleaner, right? So these are the documents that Siemens provided. So even Amatrol didn't supply these. So when Siemens got their line and they started working with this line, this is what they figured out they need to do. And we have this available for what? For every one of these lines. So these are the documents, and we got videos too. I don't think I posted those, but we got videos. But you don't really need videos because you can go up there and do what? Watch it actually work. Which reminds me, I got to do something for Nancy. So next time we get in this. So guys, what we need to do now is we'll look at the step charts. So did y'all fill out a lab form? How long did it take? Lab forms are where? So we should have did a lab form on the what? The function chart. We should have done a lab form on the step charts. Anybody do one of those? Yeah. You're thinking about Hoy, but I don't know. This is the conveyor belt. This is the one that I was assigned to do the. We did the step chart. The way we did it when we was at Tennessee is some of the groups did function charts, some of the groups did step charts, but we had a lot bigger one. It'll work. I think this will work out real good. Y'all think it's okay? Y'all, wasn't that neat? I thought it was anyway. This guy was pretty interested in that. Let's see how it works. What they do, what Siemens decided to do when they did the step charts on devices that had two different routes to go, they had two step charts, so we could look at that on y'all. One of them covers one situation. So if it's, this says, okay, if it's acrylic block, then this is the one that you use. And then it says, okay, if it's a aluminum block, then this is one. So this guy's got to make a decision on whether it's an acrylic block or whether it's a aluminum block. And then this would, but can you see something different on these? Yeah, push button. So most of these are done in manual mode, right? So these step charts, I don't know if y'all realize it, but this is done on manual mode. So most of the time, this, except for, and we're going to try to figure out how to do that. In the automatic mode, we don't even have to hit the start button, right? We just take it from what? Reset to what? Auto. So the start button only comes into play when we have it in what? We have it in step mode, right? Very few sensors on this. Can y'all see something here? Yeah, so this uses a timer, right? So once this triggers, so P1 triggers. But once it's triggered, it stays true for what? Yeah, 4.5 seconds, right? You understand? I don't know what's going on here, but it looks like this right here might be. It looks like the air should be doing something there. I would have to figure out the second. Once this is triggered by D2, it stays true for what? 1 second. Of course, we figured that out. One of the guys wanted to argue this with me about it, but I said it's got to be on a timer. And I don't see. So we need to try. What triggers this guy right here? So the Q valve cylinder. So this is they have a Q timer, and if you had PLCs, these are all software. In real life, if it was motor controls, we didn't get to that this last time, unfortunately, because the little blip we had in the program. But timers, they can be mechanical, right? You understand that, or electromechanical. These are all what? These are all software. If you take the PLC course, and if you're in the AUT program, you're going to take the PLC course. That's required. If you're in the ILT program, you could take the PLC course, but be one of your electives, and that is a really good elective to take, by the way, if you're in ILT. But you can also take ILT more electronic. There's more electronic courses. So I don't know this sort cylinder. It don't say what triggers is, and what you're going to find out, just about every bit of this stuff is triggered by what? By one of these timers. So you'll see that thing. It'll just So what's the main trigger here? It'd be B1, right? So when B1 triggers, then that basically starts everything. I'd have to look and see where B2's at. So, I'm sorry. So B2 is where? Let's go back and look at the diagram. I know where it's at. Oops, wrong way, Rich. It'd been easier to use the slide over there. Well, this guy basically he's only got 2 sensors on it. No, I'm sorry. He's got so this guy right here has got 2 sensors. What's this guy gonna do right now?
Oh, it reads when the cylinder is contracted.
Yeah, but what's the purpose of well, the acrylic block comes straight down.
Yeah, so it's directly where the block.
The aluminum blocks are pushed over, right? So how does it know? First of all, it knows something's there by what? B1. B2 is the block. So B1 tells the control logic or the controller there's something there, right? And B2, if there's something there, and if B2 don't trigger, then it knows it's acrylic. If it does trigger, it knows it's what? Metal. And then, of course, if it knows it's metal, then it goes into this guy's going to what? It should go over here. Acrylic is going to come down here. What triggers this guy right here? Timer. It's just time. It's giving us a few little problems where something happened. I think happened in this class. With the metal block, the little block got stalled over here. This guy opened after a certain amount of time. Then it didn't want to close. And the metal block just slid down there. And it didn't know what. Didn't even know it existed. Why? Because it's timer. Yeah, but you got to understand. So 95% of the time the timer works. I mean, probably even higher, more than that. So what's the advantage of using open loop over closed loop? Yeah, it's cheaper. So this is what you got to learn right off the bat. Sensors are great, but if they can get by without a sensor, if they can get by open loop, they're going to do it open loop, right? Y'all understand that? Because why? Yeah, it's a lot of money. It surprised me that Amatrol didn't put a sensor on this because of the number of sensors they put on there that they don't even use. That's not even in the program. They're available for us to come back and write programs around, but they're not in the original Amatrol program. Like the analog pressure switch. It's got an analog pressure switch on it. It's got an encoder on it. It's got an inductive sensor on the sorting station, so it could sort metal and plastic. But when they wrote the program, they just incremented every time. So the only sensors we have available on this thing is B1 and then B2, and then one B1 and one B2, right? And then where? And then B3, and that's it. So B3, what does it do? It tells it when the part finally gets to the end, right? And it also tells the robot station there's a part there. So the robot station would know to come out and pick it up. So you okay on that one? So this guy's got a lot of timing involved in it. And like I said, this was, I don't know where that guy was from, but he was arguing with me, So I'd pick up the block, so it'd start going, and I'd pick up the block and show him that even though I picked up the block, everything we did was still sequenced down. So I finally convinced it was on a timer. So ours was pretty good. They didn't think we were going to catch that, but we did. Well, the robot does know. It sends that information. The robot's got to know which side to go pick up. So there must be some information going from the sorting station. It's not sorting. What do they call that one? I don't remember. Because the robot knows whether to come to this side and pick up acrylic or that side to pick up metal. And I think if they're, and it shouldn't, and it's got to be something in there that lets it know when to feed the next part. So, that, I agree with you. Agreed. So let's see, let's go back because there's got to be something that triggers it to fig. So according to this, it starts off, receives the start input, right? And then what? Turns on the motor. And then that affects what? B1. Then it starts the timer. B2. I don't know why. Then this side would be acrylic. And then this side would be metal. This starts the 1 second timer. This extends the sort cylinder, which triggers 1B2. 1B2, well, once it hits 1B2, it will do what? Retract, right? And then that'll trigger 1B1. Once BB1 goes true, then it increments aluminum Q count, and undoubtedly this is going to let the PLC know if the Q gets full. And then this is going to release the part. Well, this doesn't tell us how it knows to release the part, but and then it says engage, part stop, decrement Q count, and motor start off when it hits what? B3. So it looks like there's something missing out of this thing. Let's go back. Let's go look.